Hello everyone, and in this video I will be going over shaders. A shader is a program that is ran on your graphics card to give you all sorts of effects. Shaders can blur up an image, shaders could do all the matrixy transformations inside. It's more powerful than what we have right now, and more powerful than what you would have gotten with the immediate mode, which I'm actually going to delete this since we're not going to be using that anymore. So, to get started, I'm going to create a new class, and I'm going to call this shader. In order for the shader to work, it's going to need a program, a private int program. It's also going to need an ID for the Vertex Shader, which I'm going to call VS, and same as well with the Fragment Shader. The Vertex Shader processes all of the vertices that the shader takes, and the Fragment Shader gives everything color, like texture and the blur and all the other good stuff. So to get started, shader is going to take in a string, and it's going to be called file name. So we can start off by importing the OpenGL of 2.0, all of it, and we're going to create the program with GL create program. Oh, my bad. Make sure you put static by the import. And we now create the program. So we could also create the Vertex Shader by doing GL create shader, and for the type we'll do GL Vertex Shader. So we create the shader, and the shader type is the Vertex Shader, so OpenGL knows exactly what to do with it. Now we need some way to read from our source. So I'm going to create a private method. It's going to be a string, and I'm going to call it read file. And it's going to take in the string file name. So to get started with this, we'll need two variables. We're going to have a string builder. This is where all the contents within the file goes. I'm going to call this string. Make sure it's equal to a new string builder. And we're also going to need a buffered reader. I'm going to call this BR. So now within try, make sure you catch an IO exception and print the stack trace. Make sure BR is equal to a new buffered reader, and this takes in a reader. So a perfect reader for our file would be a new file reader, which is also going to either take in a string, file descriptor, or file, and we're just going to go with a new file. And the location of our shaders is going to be /shaders. And go ahead and add another slash, and then we'll add the file name to the string. So now we have our buffered reader, and with this we can decode and get all of our data onto it. So make sure you import everything, including the file. If you're using Eclipse, you can press Control, Shift, and O, and that'll do everything for you. And it'll also reorganize this, which we'll change that later. So after we've created our buffered reader, we can get all of the text on the file. So I'm going to create a string, and I'm just going to call this line. So now we'll have a while loop, and within the while loop we're going to be setting line to equal br.readLine, and this is also inside the parentheses, and we'll put not equal to null. So for every loop, we're basically setting line to read line, and if it is null, we break out of the loop. But if it's not, then that means there's a line of text in the file that we can process. So all we have to do now is do string append, and we'll do line. Now that's almost pretty much it, except OpenGL wants it exactly like a file. And after every file, it breaks a line. But the buffered reader isn't reading that, so we actually have to append that ourselves. So we'll have to append \n. And \n, if you don't know, it basically means a new line. So after we did all that, all we have to do now is close the buffered reader, and outside of the read file, outside of the try, we'll return our string to string. Awesome. So now that we have finished our read file method, we'll pass in the source to our Vertex Shader. So all we have to do for this is do GL shader source. And this is going to have our Vertex Shader and read file, file name, and we'll add .vs. This is the ending to our file, .txt, .exe, and all that stuff. Except this is ours. You can go ahead and use .vert, .shader, whatever you want. It's as long as you have it as the same as that, you're fine. So I'm actually going to change this back to import static with the star, so that way we get everything. And now we have to compile the shader. This is actually quite simple. It's just GL compile shader, and then the ID of our shader. But now, what if we have an error in our shader and we didn't know about it? Well, this is where we check the error for our shader. So to check it, we'll put an if statement, and we'll use GL get shader I. And of course, this will be our shader ID, and the p name is what we're grabbing with the error. So for the p name, we'll use GL compile status. And if it's not equal to 1, so if it is 0, it means there is an error with the shader. But if it's 1, it's good. We can continue. So we'll use system.error print line, And we can go ahead and do gl get shader info log, and then our vertex shader. This is basically getting what the error is. It'll tell us like line 5, this is not a variable or something. And we're printing that out to the console. And since there is an error, we can just do system exit 1. Now all we have to do for the vertex shader is practically the same thing. So I can just copy this, paste it, and change everything that is needed. So VS will be FS. And Vertex Shader will actually be Fragment Shader. So we have FS to create a shader, the Fragment Shader. We're sending the source of filename.fs to our FS shader. We're compiling FS, and we're checking FS. So after we do all this, we can now attach these shaders to our program. All we do is this method, gl attach shader, and it's going to be our program, and we'll start off with VS. And then we'll do attach shader again with FS. So now we have our shader attached to the program. So, since we're using version 1.2.0 of the shader, there are these things called attributes. And each attribute location is basically what our model class will be sending to the attributes. So if we have an attribute 0, and that's for our vertices from the model class will be sent to that attribute. So we can do this by gl bind attrib location with our program, and the index will be what it's using. So of course the first one is going to be 0, and 0 is going to be for our position, or the position, the vertices, you can call it whatever you like. I'm just going to call it vertices. So if you have the same thing for texture coordinates, you'll do the same thing, except 0 would be 1, and then instead of vertices it would be text chords, etc. But we're only going to be using vertices for now. So now all we have to do is to link the shader and validate the shader. We can do this by gl link program and gl validate program. Of course, there will be some errors between the two, so we'll have to check the error. So instead of get shader I, we'll use get program I. And of course it'll be our program, and the error type we're looking for is gl link status. And not equal to 1. And of course we'll system error print line gl get program info log and our program, and we'll exit if there is an error. So we can go ahead and copy this, paste it under validate program, and change link status to validate status. we are now finished generating our shader. All we have to do left in this class is create a new method, and we'll call it bind. And all we have to do is GL use program and our program variable. Good. We have finished our shader class. Now all that's left is to create a shader. So I'm going to create a new folder in the workspace, and I'm going to call it shader. Exactly like it is. Oh, it's shaders. Refactor, rename, shaders. Okay, so it's shaders, and we can now create our new file, and this is going to be called shader.vs, and we'll create one more file, and it'll be shader.fs. So under shader.vs, we'll do pound or hashtag or whatever you want to call it, version 120. This is setting the version of OpenGL so OpenGL knows what we want to do. And now we have to have the attributes. So we'll type in attribute vec3 vertices. So that's what it's called. That's what it's called. So now we create an attribute, and it must be the same name as what you have used to bind the attribute location. In my case, it's vertices, so I type in vertices right here. Now for the main method, which is void main. So kind of like if you were programming in another language, it would be the same way. And to set our positions, the vertices, you don't return anything, but you set a value with GL position, and that is equal to our vertices. But there is one problem. GL position is a vec4 variable. So what we do is we type vec4, and then we can pass in our vertices, and the last variable will be 1. Alright, now that we have finished our shader, Vertex Shader, we can now go on to the Fragment Shader, which will be the same, start version 120. And this time we don't need an attribute. An attribute is a Vertex Shader only. So we'll do the void main again. And this time we'll do GL frag color, and we'll set that to vec4, and we'll go with a red. So that'll be, the red will be set to 1, green 0, blue 0, and alpha will be 1. Okay. Now that we have finished that, we can go back into our main class, and we can create our shader. So for now, I am going to comment out the texture, and we'll create a new shader. And the file name is going to just be shader. So now that we have created our shader, before we render the model, we want to do shader. We need to shader.bind. We need to bind the shader before we render the model, so that way the shader is being used. So now when we run it, we should have a red quad. In the next video, I will be going over uniform variables within glsl. This way we can get our texture back and running. So, I will see you in the next video.